Hello everyone, welcome to my presentation on exploring diffusion. Today we will dive into the fascinating world of particle movement and observe firsthand how substances disperse through different mediums. Diffusion, as many of you may know, is a fundamental process in nature, critical for various biological, chemical, and physical phenomena. It plays a vital role in processes like osmosis in cells, the mixing of pollutants in the atmosphere, and even the flavoring of our favorite beverages. The purpose of this presentation is to showcase 3 experiments I conducted to better understand diffusion. Through these experiments, we aim to unravel some of the mysteries surrounding this fundamental concept. Now let's dive into Experiment 1, where we investigated the effect of temperature on the rate of diffusion with tea bags in different temperature conditions. In this experiment, we prepared 3 containers of water, one filled with cold water, one filled with room temp water, and the third one with hot water. Each container contained a tea bag, and we observed how the temperature of the water affected the diffusion of tea particles. As we immersed the tea bags, we tracked the color change and diffusion pattern over time in each temperature condition. In the cold water, diffusion seemed sluggish, with the color change taking longer to spread throughout the container. On the other hand, the room temp water, we noticed a more rapid diffusion, indicating that higher temperatures promote faster particle movement. However, it was in the hot water where we observed the most drastic results. The tea particles dispersed rapidly, creating a distinct color change throughout the container. These findings highlight the significant impact that temperature has on the rate of diffusion. By changing the temperature of the medium, we can effectively manipulate the speed at which particles spread, influencing various natural and industrial processes. Now let's shift our focus to Experiment 2, where we investigated the role of agitation in diffusion using tea bags and water. In this experiment, we set up 2 identical containers of water, each containing a tea bag. In one container, we kept the water still, while in the other, we agitated the water by gently stirring it. In the container where the water remained still, diffusion occurred gradually, with the color change slowly spreading from the tea bag to the surrounding water. On the other hand, the container where we stirred the water, we noticed a much more rapid diffusion process. These results underscore the significant impact of agitation on the rate of diffusion. By introducing mechanical motion to the system, we effectively enhance the mixing and dispersion of particles, accelerating the diffusion process. Now let's talk about Experiment 3, where we compare diffusion in different mediums using Kool-Aid and water and oil, considering the influence of viscosity. In this experiment, we prepared 2 containers, one filled with water and one filled with oil. We then added the Kool-Aid powder to each container to serve as our solute. In the water container, we observed rapid diffusion, with the Kool-Aid powder quickly dissolving and spreading throughout the water. This rapid diffusion can be attributed to water's low viscosity, allowing for easy movement of the solute particles throughout the solvent. However, in the oil container, we encountered a different scenario. Due to the oil's higher viscosity compared to water, the Kool-Aid powder did not dissolve as readily. These results highlight the significant role of viscosity in the diffusion process. Viscosity, or the resistance to flow, influences the ability of a solute's particles to evenly disperse throughout a solvent. In conclusion, our exploration of diffusion has provided valuable insights into the fundamental processes governing particle movement. Through our experiments, we observed the influence of factors such as temperature, agitation, and viscosity on the rate and extent of diffusion. Thank you for listening to my video on diffusion. Please let me know if you have any questions.